So we're most of the time we're going to deal with regular polygons, and that just means that all sides are equal and all angles are equal as well. So you know your square, you know your triangle, equilateral triangle. Those are technically considered regular polygons. Poly means many, gons, many angles. So many angles, many sides. So we have our convex polygons, which just make a shape that is closed like that. And convex will have and we're going to highlight this angle right here on the inside. And for a convex polygon, all interior angles are going to be less than 180 degrees. So all the interior angles on the inside are going to measure less than, and a concave has an angle greater than 180. So it's a reflex angle there, right? It's going to be greater than 180. Just need to know those terms. All polygons have interior, sorry if I'm speeding up a little bit, but I want to get these notes in, and exterior angles. So this one is one where you might want to, if I'm going a little bit too fast, take advantage of the video later. They will always be supplementary. I want to add, they will always have an interior, and we use capital I, if you can, capital I. Exterior, we normally use capital E for that, right? So all polygons have interior and exterior angles. They will always be supplementary. So that's something that you might want to look and highlight. Okay, so I'm gonna demonstrate this with an equilateral triangle. So try to make it look like all three sides are equal in length. Each on the inside, this is a triangle that has three interior angles. Maybe I'll use a red pen here. There's an interior angle there, there's an interior angle there, and there's an interior angle there. So three interior angles. And do you remember what they are? They're always 60 degrees, right? 180 divided by 3 essentially. So if you can, I'll just put my blue pen is dying here. 60 degrees, 60 degrees, 60 degrees. So I know it's a lot there, but I'm going to try to demonstrate the interior and exterior angles here. So once you have drawn this, okay, let's go to this corner together, right? To the right bottom here. we're now focusing on this one. So we're gonna start at the corner and just kind of make a dashed line going out. So we're almost extending that baseline. Okay. Then we're gonna travel up this triangle to the top corner and extend that side like that. And from the top, we're going to travel down and extend that line like that. Almost looks like a water wheel, right? And so you have three interior angles, and what you will now see is that you have one exterior angle. There's another one right here. That's an exterior angle. And there's another one right here, another exterior angle. So you have three exterior angles. For every interior angle, there is one exterior that supplements it. See? They're right next to each other. And you're like, Mr. Erickson, couldn't I have extended this line here this way? Yeah, but then you cannot use this one. Like every corner only has one exterior angle. Don't make more than one, right? And so if this is 60, then I know that the outside is going to be 120 because together they add up to 180, right? They're supplementary. So if you know the interior angle, it's easy to find the exterior. You just subtract it from 180, and it could be vice versa. I could give you the exterior angle, you subtract it from 180, you get the interior, and so forth, right? And so you have, watch this, it's important. I know it will seem basic. Three sides, three interior angles, three exterior angles. Right? So notice the 3, 3, 3. So if it's a four-sided shape, it'll have four interior angles, four exterior angles, and so forth, right? That's the pattern I want you to see. And in general here, the exterior angle plus the interior angle will always be supplementary, right? And from that, we can derive the two equations that come from this, right? If you want to know the interior angle, you're just going to go 180. The E, the exterior angle, comes over to the other side, subtracting. Right, so that's one version of it. If you want to know the exterior angle, you go 180. And the I, the interior angle, comes over subtracting. And so there you have your three formulas. But the most important one is this one here. Right, to understand that concept, because I'm going to test you on it in different ways, like to know that you remember this property, right? Very important. Okay. And another important comment here, note, sum of exterior angles is always 360 degrees. And note the always, right? Regardless of the number of sides. Okay, that's maybe equally important. So notice here, right, you had three 120s. So 3 times 120 is 360, right? But what about a square? What does each angle in a square measure? 90, right, on the inside? What will be the exterior? It will also be 90. So 4 times 90 is 360. And so this pattern, it's always true. This is always true, okay? Sum of exterior angles is always 360. I got that. Okay, let's keep going. We're gonna talk about formulas, which are a must on your formula sheet, or I should say your study sheet, right? And just write them down for now. Add to study sheet for sure. So sum S of n, right? Just write it down exactly that way. N minus 2 times 180 degrees. This represents the sum of interior angles, and n represents the number of sides. That's for every single one of these, n represents the number of sides of that particular polygon. Maybe leave 2 lines in between. I of n is going to be n minus 2 times 180. Notice that it starts the same, but then it's going to be divided by n. Okay, and that tells you the measure of each interior angle. Then you have C of n, and that's a pretty easy one. It's 360 divided by n. The measure of each central angle. E of n, it's going to be exactly the same as the central, and later on we'll see why that is. And it's the measure of each exterior angle. And here it comes up again, right? Why are we taking 360 and dividing it by the number of sides? Because the sum of all exterior angles is always 360, so we'll just split it amongst the number of sides, and then we get it, right? And then D of n, this one is trickier, n times n minus 3 divided by 2. And this one gives you the number of diagonals that can be drawn. And I'm just going to zoom out once, because I want you to see the overview here. Overall, out of all these 5, right, these 3 here, that's why I group them up. Sorry. These 3, ice, right? Think of ice. You don't really want to think of it anymore. You're happy summer is here, right? This is only true for regular POLYS. I'm just going to go POLYS there so that it fits. So those 3 only apply if it's a regular polygon, because you're assuming they all measure the same. So when you're dividing by the number of sides, you're assuming they're all measure the same. That's why when it's divided by n, watch out, that is only going to be true for regular polygons. And this is always true. And this is also always true. Okay. So study sheet, okay? Like whatever you do after today, put it on your study sheet. And now we're going to label all of these. I'm going to show you. You can really only label ice on there. So let's try a pentagon. That's the one that I'm okay with. Okay, so you start with the roof of the house kind of thing, and then just try to make a pentagon if you can, 5 sides. Try to find the center of it as best as you can. And the center is important because if you go from the center to any corner, so let's slice it there and then slice it there, right? The angle that is formed by these two legs that you just drew, that's called the central angle, right? So you have, by the way, there are 5 central angles, all right? There's 1, 2, 3, 4, 5. Like every slice of pizza has its central angle, but this will be considered a central angle right there. Let's go to one of the corners itself, like one of the corners of that big polygon, and that would be considered the interior angle. And there are 1, 2, 3, 4, 5 in this case interior angles, right? But we're just labeling 1. And the exterior, because the interior is here, I'm going to choose to label the exterior here. So you either extend the line this way or you extend this side that way. It's up to you. But I'm going to extend it sideways. I'm going to extend this side sideways. And so that one right there is my exterior angle. And there are also 5 of them all around. Okay. And let's calculate, let's try apply all these 5 formulas with this one. Pentagon, that means that n is equal to 5. Okay, you just count it. The name says it all, but I will give you the names and the number of sides later. That'll be tomorrow. And so sum, you want to know the sum of all interior angles in this pentagon. So S of 5, that'd be 5 minus 2 times 180 degrees. So S of 5, that'd be 3 times 180. So S of the pentagon, that's 540, right? Making sure, 540 degrees. So if they asked you for the sum of all the interior angles in this particular polygon, is 540 degrees. Okay, let's try the other one. I of n, I of 5 would be 5 minus 2 times 180 degrees divided by n, which is 5. That's 3 times 180 divided by 5. So it's essentially 540 divided by 5, right? And that is 108 degrees. That's the interior angle of this pentagon. Every single interior angle measures 108 degrees. Okay, that's why you divide by 5. And we'll just go around. Central angle of 5, that's just 360 degrees divided by 5, right? And you get 72 degrees. The exterior angle, you have 2 options. You go 360 divided by 5 as well, or remember the formulas I gave you earlier? What are I and E are what? I and E are supplementary. So to get the exterior here, you just go 180 minus the interior. 180 minus 108, the exterior angle is 72. This is very important to know, to not just know how to use this formula this way, but also know how to use this other one that I gave you previously on the page before this. Diagonals, that'd be 5 times 5 minus 3. I'm just using the formula, divided by 2. Okay. And that is really 5 times 2 over 2, and that is equal to 5. This is how many diagonals you could draw on this particular pentagon. And you're saying, what? So here's where colors come in. So if you could, and then we're going to dismiss soon. If you could draw diagonals from this corner, you could go 1, 2, then you're out, right? You can't go more because this is not a diagonal. These are actually sides. So count with me. 1, 2. Then I'm going to go to this corner. And I'm going to go 3, 4. And I'm out of different colors here. So that's all I have. And 5. Right? There are your 5 diagonals. 5 diagonals. You can do some beautiful art with that as well. Okay. All right. This is all I have for now. Let me just see homework. I don't have enough for you to do this kind of homework. So please go back and check if you have done all the homework that I assigned before. So no textbook. I had this one page here that I wanted you to do. Page 23. Homework, page 23 and booklet. Plus anything, plus any missing homework from before. Okay, make sure you go back because I posted all the answer keys. It's very important for you to know